So moving forward on the next theory, which is Bronsted Lowry concept. He proposed that proton donors are acids and proton acceptors are bases, right? He only considered the theory of proton. If I write proton acceptors and proton donors. Proton means H positive, this H positive. So proton acceptors are bases and proton donors, which can donate its H positive ion, is an acid, right? So let us consider some examples from this theory. For example, if I write a reaction between HCl and ammonia, right? Hydrochloric acid and ammonia. So reaction is like this. Cl negative plus you get ammonium ion, NH4 positive and Cl negative. If you see clearly, this HCl has been converted into Cl negative, means it has donated its H positive to this H positive has been shifted here to form NH4 positive, right? Again, HCl has been converted into Cl negative by donating its proton to ammonia. Ammonia, on the other hand, it has accepted this acceptor, proton acceptor, whereas this is proton donor, right? So proton donor and proton acceptor. Proton donors are acids, whereas proton acceptors are bases, right? So HCl is an acid, whereas ammonia is a base, correct? Considering another example, if I take, suppose I take H2O plus, say, carbonate, CH3, 2 negative, right? If I complete the reaction, you'll get HCO3 negative plus what will get? OH negative ion, right? So if you consider carefully, we have here, just a minute, we have water has been converted into OH negative ion. So water has removed its H positive ion. It has donated its H positive ion. Donor is an acid, proton donor is an acid, whereas CO3 2 negative, that is carbonate ion, is converted into bicarbonate ion, right? Because it has accepted H positive. This is acceptor of H positive ion. It is a base, right? So any substance which accept protons is a base, and any substance which donate its proton is an acid. Bronsted Lowry concept, right? Now another term which will come into picture is amphoteric substances. See, there are many substances which shows the property of base also and a acid also, right? For example, water. Water, if you consider, water is amphoteric in nature. Amphoteric means it has both the properties to accept a proton as well as to donate a proton, right? So water in presence of an acid. Suppose if I take HCl here. HCl is an acid, right? Everybody knows HCl is an acid. So in front of an acid, water will behave like base to give us now what an acid does. Acid donates its H positive. It is donor of this proton, whereas base is an acceptor of H positive ion. So can you write the products? Donor means it has donated, so it will become Cl negative, whereas water, which is acting like a base in front of an acid, will accept H positive ion to form H. Total number of H would be 3 now. oxygen and a positive charge. Why positive charge? Because initially it was neutral. It has gained H positive, means it has gained a positive charge. तो जब इसके पास पॉजिटिव चार्ज आएगा न्यूट्रल से तो +1 का पॉजिटिव चार्ज has to be represented like this, right? So chloride ion and hydronium ion, right? And amphoteric nature जब बतानी है तो you have to show both the type of examples. That is when water is acting like a base shown, right? Now consider another example where water will behave like an acid. Acid कब behave करेगा? जब सामने क्या हो? कोई base हो, right? So base का example ये पढ़ते आ रहे हैं ammonia. Let's take ammonia. Now this time if ammonia is there, it is a base. Base are proton acceptors, right? And acids are proton donors. So as soon as we write a reaction, we'll get the product. Likewise, example, if it has donated its H positive ion, so it will convert into OH negative ion. This water will convert into OH negative ion, whereas base which has accepted a H positive ion will convert into NH4 positive. This is ammonium ion and hydroxyl ion, right? So we have written an example of amphoteric substance, which is water. Water in presence of an acid will behave like a base, and in presence of a base, it will behave like an acid. We have shown all the both the examples, right? Another example, if I consider for an amphoteric compound is your bicarbonate ion. Bicarbonate means HCO3 negative. This is bicarbonate ion. Bicarbonate. So bicarbonate in presence of, let us take the example of acid and bases similarly, like ammonia and HCl. So ammonia plus HCO3 negative. Let us take the same examples. I mean to say ammonia base. In front of an base, it will act like an acid. It is base. HCl is an acid. HCO3 will act like a base, right? So just write the corresponding products. If it is acting, this bicarbonate is acting like an acid, so it will donates its H positive. This H positive is accepted by ammonia because it is acting like a base, right? So ammonia will accept H positive ion to form ammonium ion, and bicarbonate will donates its H positive ion to form carbonate. Similarly, now in front of an acid is proton donor. So it has donated its H positive ion to form Cl negative, whereas HCO3 negative, that is bicarbonate ion in front of an acid, will behave like a base. Base will accept the H positive ion to form H2CO3. What is H2CO3? It is your carbonic acid, right? So there are certain substances which are capable of donating as well as accepting protons, which are known as amphoteric compounds, amphoteric substances. I hope this is clear. Amphoteric substances, right? Moving towards the next topic of this theory only, which is conjugate acid-basis pair, right? What is conjugate acid-base pair? It is actually formed when you write a reaction between acid and base, and what happened is that pair contains a proton donor and a proton acceptor. That is, the pairs of acids and bases which are formed from each other by gain or loss of H positive ion. For example, let me take an example and we'll understand it. For example, consider this example. HCl and ammonia. We have already done it before, right? So it will give us Cl negative plus NH4 positive, correct? Chloride ion and ammonium ion. अब क्या होगा? HCl जो है तुम्हारा, HCl ये एसिड है, right? Ammonia is a base. Everybody knows that. टिल नाउ हमने ये सब थ्योरी पढ़ ली है, एसिड क्यों है, बेस क्यों है, अमोनिया, HCl, सब चीजें पढ़ ली है, राइट. सो एसिड्स अकॉर्डिंग टू दिस थ्योरी इज प्रोटॉन donor, right? And bases are proton acceptors. Now एसिड बेस पेयर देखो क्या है. एसिड से तुम्हें क्या मिला, एसिड से ये मिला Cl नेगेटिव, ठीक है. तो एसिड इज गिविंग यू Cl नेगेटिव. एसिड से क्या बनता है, कॉन्जुगेट बेस. जस्ट रिमेंबर, एसिड जब अपना H पॉजिटिव आयन रिलीज कर दे, बिकॉज एसिड क्या है, कोई भी कंपाउंड जो H पॉजिटिव आयन डोनेट कर दे. तो whenever it donates its H positive ion, तो जो स्पीशी बचेगी, जो स्पीशी रही है आफ्टर द रिमूवल ऑफ H positive ion इज नोन एज कॉन्जुगेट बेस, राइट. सिमिलरली अगर कोई बेस है, बेस क्या करता है, प्रोटॉन एक्सेप्ट. तो जब कोई बेस प्रोटॉन एक्सेप्ट कर ले तो इट विल फॉर्म, बताओ, इट विल फॉर्म कॉन्जुगेट एसिड, राइट. I hope this is clear. An acid will give rise to a conjugate base, whereas a base will give rise to a conjugate acid. This is conjugate acid-base pair, right? Also, if I talk about the strength of conjugate acid and base, talking about strength. So always remember that if I sum this up, suppose HCl स्ट्रॉन्ग एसिड था, राइट. HCl तुम्हें पता था क्या था, इट इज एन स्ट्रॉन्ग एसिड. वाई स्ट्रॉन्ग एसिड, बिकॉज इट डिसोसिएट कंप्लीटली इनटू इट्स आयन, राइट. सो कॉन्जुगेट एसिड इज गिविंग एसिड इज गिविंग यू conjugate base, right. If strong acid is there, it will form a weaker conjugate base. Strong से weak बनेगा, weak से strong बनेगा. ऑपोजिट पेयर जो भी बनेगा उसका कॉन्जुगेट, वो स्ट्रेंथ में उसका ऑपोजिट होगा, राइट. फॉर एग्जाम्पल, इफ आई राइट वीक एसिड, सपोज कोई वीक एसिड था. वीक एसिड का एग्जाम्पल तुमने पढ़ा है, बोलो क्या था, CH3COOH, एसिटिक एसिड. सो एसिटिक एसिड विल फॉर्म व्हाट, CH3COO नेगेटिव आयन प्लस H पॉजिटिव. सो जो ये एसिटेट आयन है, ये क्या रहा, ये क्या है, एसिटिक एसिड का कौन सा पेयर है. अगर ये एसिड है तो ये कौन सा पेयर हुआ, इसका कॉन्जुगेट बेस हुआ, राइट. एसिड कैसा था, वीक एसिड था, तो कॉन्जुगेट विल बी अ स्ट्रॉन्ग कॉन्जुगेट बेस. आई होप दिस इज क्लियर. अ स्ट्रॉन्ग एसिड गिव राइज टू a conjugate base which is weaker, whereas a weaker acid will give rise to a conjugate base which is strong. Similarly, strong base will give you a conjugate acid which is weaker, right. And weaker base will give you a conjugate acid which is stronger. Strong, weak का मतलब strength. We are talking about the strength of an acid and a base, right? So this was conjugate acid base pair की एक chemical reaction लिखा. Chemical reaction में acid part एक तरफ, और जो acid part after donor बन रहा है वो तुम्हारा conjugate base है. Similarly base है, base after accepting a proton will give you conjugate acid. If you talk about the strength, तो acid अगर strong हुआ तो उसका conjugate base weaker होगा, and whereas अगर base strong हुआ तो उसका conjugate acid weaker होगा, vice versa, right. I hope this is clear. So if I talk about this concept, Bronsted Lowry concept, तो पहले वाले की डिसएडवांटेजेस आई होप तुम्हें याद होंगी. अर्हीनियस की कुछ डिसएडवांटेजेस थी. फॉर एग्जाम्पल, वो नहीं बता पा रहा था कि अमोनिया NH3 एसिड या बेस क्यों है. देखो, अमोनिया बेस है, राइट. अभी पता चला कैसे, बिकॉज अमोनिया यू हैव सीन इज एक्सेप्टिंग अ प्रोटोन, राइट. प्रोटोन एक्सेप्टर्स आर बेसिस. तो अमोनिया गिव राइज टू अमोनियम आयन आफ्टर एक्सेप्टिंग अ प्रोटोन which is basic in nature, right. Another advantage is कि अभी तक कहीं पानी जरूरी नहीं था, ठीक है, क्योंकि अहीनियस में हमने पढ़ा कि यू नीड एक्वस मीडियम ओनली, वेर एज इसमें जो तुमने फर्स्ट एग्जाम्पल लिया CH3 प्लस HCl, राइट, तो इसमें कहीं पानी कहाँ यूज हुआ, नो वे वाटर वाज यूज्ड, राइट, सो वी हैव नॉन एक्वस मीडियम विद अस, सो NH4 पॉजिटिव प्लस Cl नेगेटिव। इसी थ्योरी से हमने बता दिया विदाउट यूजिंग वाटर, विदाउट यूजिंग एक्वस मीडियम, कि हाँ what is our acid and which of the following is our acid and which of the following is a base, right? And also if I consider this example, तुम्हें याद हो तो, बाइकार्बोनेट, सी, बाइकार्बोनेट और अमोनिया में क्या डिफरेंस है, अमोनिया is a neutral compound, right, it is a न्यूट्रल कंपाउंड, न्यूट्रल कंपाउंड मतलब इस पे कोई चार्ज नहीं है, वेयर एज बाइकार्बोनेट इज एन आयनिक स्पीशी, देखो इस पे -1 चार्ज है। तो एक जो बड़ी एडवांटेज आई तुम्हारी ब्रॉन्स्टेड लोरी कॉन्सेप्ट की, इट इज कि इट डज नॉट only consider the neutral molecules to be acids and bases, whereas it tells the acidic and basic strength of your ions also, right? So this concept is not limited to molecules, but also your ionic species, right? So these were the advantages of Bronsted Lowry concept. I hope it is clear, right? Moving towards the disadvantage, if I talk about the limitations, क्योंकि नेक्स्ट थ्योरी भी तो पढ़नी है, तो इसकी कोई लिमिटेशन रही होगी, तभी हम नेक्स्ट थ्योरी पे जा रहे हैं। तो नेक्स्ट थ्योरी, फॉर एग्जाम्पल इफ आई टेक, लेट अस कंसिडर अ रिएक्शन CaO and SO3, ये दोनों क्या है, ऑक्साइड्स हैं, एक कैल्शियम का ऑक्साइड, एक सल्फर का ऑक्साइड, ठीक है। तो इट कैन नॉट एक्सप्लेन द रिएक्शन बिटवीन एसिडिक ऑक्साइड्स, दोनों क्या है, एसिडिक ऑक्साइड्स, ठीक है। क्या बन रहा है, CaSO4, इस रिएक्शन को ये एक्सप्लेन नहीं कर पाया कि क्या एसिड्स है क्या बेसिस है। इसमें क्या देखा उसने, दोनों एसिडिक, रिएक्शन बिटवीन एसिडिक ऑक्साइड्स को एक्सप्लेन नहीं कर पाया, किसके बीच में, रिएक्शन बिटवीन एसिडिक ऑक्साइड्स, right? Another example, another limitation was कि consider BF3 or you can say aluminium chloride AlCl3। अब ये दोनों क्या थे, substances like BF3, this aluminium chloride are known to behave as acids। इनको ये क्या है, ये acids हैं। अब एसिड्स क्या थे, अकॉर्डिंग टू ब्रॉन्स्टेड लोरी कॉन्सेप्ट, विच कैन डोनेट H पॉजिटिव आयन, बट इन दोनों केसेस में तो कहीं H पॉजिटिव आयन है ही नहीं, फिर भी ये एसिड्स कैसे दिखा सकते हो बाय दिस कॉन्सेप्ट, राइट? सो वी कैन नॉट शो कि हाँ ये एसिड्स है, बिकॉज दे डू नॉट कंटेन H पॉजिटिव आयन टू डोनेट इट, दे आर नॉट प्रोटॉन डोनर्स, राइट? सो दिस विल स्टडी इन द नेक्स्ट कॉन्सेप्ट विच इज योर लेविस कॉन्सेप्ट।